So do you know about the parallelogram law of vector addition? Okay, no problem.
No.
Okay, okay, no problem. So parallelogram law. So this law is for calculating the two vectors, resultant of only two vectors. Suppose here is a vector, a vector in this direction, and from this point there is another vector which is vector v. So actually this is a geometrical concept. So what will we do? We draw a line which is parallel to this line from this point, okay, like this. Like this, okay. And after that from this, from the tip of this arrow, we will draw a line which is perpendicular to this vector, okay. Sorry. So if you do this, then you will get an intersection point, and after that if you join this from here to here, intersection point, this will be your resultant of vector. The length of this is the resultant vector. Okay, and there is one thing more. Same diagram, I am drawing the same diagram. So instead of this, if I want to calculate the resultant R, in this case we should have the geometrical tools like scale and all that. We have to measure the length, and these all things will be performed on the graph, okay. But we have to solve the question. So what you should do, if there are two vectors and the angle between those two vectors is theta, there is a formula to calculate the resultant. Resultant is given by the magnitude of resultant, or you can say resultant R is given by magnitude of A square plus magnitude of B square plus 2 magnitude of A magnitude of B and cos of theta it in between the vectors. So in simple words, I want to write this formula like I can write this like A square plus B square plus 2AB cos theta. Here A I have replaced a vector. Me always remember that this is I can write like this. Okay.
Yes, sir.
That, so you should remember this. There is no requirement of this, I think, but you should remember this formula at least. This will be used in the questions. Now, from this form, with the help of this formula, we can drive some special cases like when two vectors are parallel, when two vectors are anti-parallel, when two vectors are perpendicular. Okay, so when two vectors are parallel. So parallel means the angle between the vectors is 0 degree. Here is a vector A vector and here is another vector. It can be a B vector. B vector. These vectors are parallel. These vectors are parallel, like parallel lines. So the angle between the parallel lines is 0 degree, means the angle between the parallel vectors. Vectors are nothing but they are like arrows. This is the tail and this is the head of the arrow. And this is just a way of representing the vector, nothing else. So if I want to find the resultant of this, then I can write directly R is equal to, directly I will add A plus B. And this result can be derived with this formula, but you should remember this. In the same way, when two vectors are anti-parallel, when two vectors are anti-parallel, this is a parallel, this is anti-parallel. Anti-parallel means you can say this is one vector and going in this direction and there is another vector like this, you can say. Okay, so this is a vector and you can say this is, means the direction of two vectors are opposite, B vectors. So if you want to calculate the resultant means the magnitude of vector summation, then simply subtract A minus B. Remember, this is the magnitude, okay? And there is one more case, and this is the last case. When two vectors are perpendicular, means here is one vector, and from this point there is another vector. Okay, and this angle is 90 degree. Perpendicular means the angle between two vectors is 90 degree, and this is A vector and this is B vector. So I can write the resultant directly. R is equal to under root of A square plus B square. Now I will derive this result by this formula. This is the general formula for vector having angle theta. Now what should you do? Make this angle 90 degree. When you make this angle 90 degree means V is like this. V will come here. Okay. Means V will come at this position, means this angle will become 90 degree. So from here you can put the value of theta in this and you can get the result. Okay. So what I am going to do here, I will use the formula. We have formula like R equal to under root of A square plus B square plus 2AB cos theta. So I want to calculate the value of R. So what will I do? Like I am writing magnitude of A square. This is A square. This is B square plus this is 2AB cos 90 degree. And the value of cos 90 degree is equal to 0. So this whole term will become 0. Now we have only this A square plus B square. So you can remember this also. And there can be another case is also when the angle between two vectors is 60 degree, 30 degree, 45 degree, then accordingly we will change the angle here. Okay.
Yes, sir.
Like there is a case like this is just an example. Like here is a vector A. I am not taking A, I am taking a force. Here is a force of 2 Newton and here is a force of 3 Newton and angle between them is 30 degree. So we can calculate the resultant like this. A square plus B square means A square means 2 square plus 3 square plus 2 into AB 2 into 3 into cos 30 degree. And this value we can calculate. Okay.
Yes, sir.
So this is all about the vectors, and the most important part of this is this formula. This formula and these results are most important. We will use these results directly in the questions. Okay, so please note it down. And
Yes, sir.
okay. Should I scroll down?
Yes, sir. Thank you. Yes, sir.
Done?
Yes, sir.
Okay. This one completed?
Yes, sir.
Okay, fine. So there is another concept we will discuss here, like equilibrium. Equilibrium. Do you know something about equilibrium?
Yes, sir.
Please tell me.
So if there's more of something on the in one side and then there's less of the same thing on the other side, then suppose water will flow from a higher concentration to a lower concentration.
Yeah.
And
Means
other
you are
things.
just saying. I have understood. You are just saying equilibrium means the stability. Stability.
Yes, sir.
This is okay. So in physics, in chemistry also, equilibrium is the stability of any body. Like you have told me that water always flows from higher pressure to lower pressure because water wants stability. Okay. So in there are many methods. There are many methods you can explain the equilibrium. Okay. So equilibrium means the net force on the body is zero. F is force, net force on the body is zero. Like here is a body here, and this is a force of 5 Newton, and here is a force of 6 Newton. So means this fall because the force in this direction is more. This we can feel. So this body will move in this direction. So this body is not the equilibrium. Okay. But instead of 6 Newton, Here is 5 Newton. So this body will be at rest. So we can say the condition of rest of a body is the equilibrium condition. Here, this is the point. So here you can see the net force on the body is 0. How now, like, look here, this is the body na, so you can take this is a point. Like here are two forces which are acting in opposite direction. I have told you na, anti-parallel vectors. This
Yes,
is the
sir.
case na, anti-parallel vector. And if you want to calculate the resultant of the vector means force, F net. If you want to calculate A minus B, 5 minus 5, that will be 0 Newton. There is no force on the body means this is the condition of equilibrium. Okay. Let us come to our electrostatics part. The starting chapters like electric field and charges, and after that electrostatic potential and capacitance. These are little bit tough chapter. I believe that, because in these chapters we use the concepts of 11th class. Okay, so that's why these are tough for the student. Feel that these chapters are tough because they have forgotten all the concepts of 11th. That's why. But we have to study this. So two charges plus E. E is the charge on proton, you can say, or electron, and plus 4A are placed at a separation at a separation A. At what point? At what point on the line joining the two charges? On the line joining the two charges, a charge Q is placed so that charge Q is in equilibrium. Give me a minute. Okay, how? So this is the question. Simply, we will follow the statement of the question. Here is a charge and here is a charge. This is the line joining between the two charges. and you can put any charge anywhere. I am putting plus E charge here and plus 4E charge here. And I have to put a charge. I have to put a charge on a position it in between on the line joining of these charges. This is the line joining. I have to put the charge on this line joining the two charges so that the Q charge is in equilibrium. Means that we have discussed equilibrium means the net force on the charge Q is 0. Okay. So if I am putting the charge, suppose here, this is the separation given A, na? Okay. Now I am putting a charge here. This is Q. And Q means if no sign, then we will consider it as positive charge. So this is Q. And we will check whether this is in equilibrium or not. So please look here carefully. Due to this charge at this point, the direction of force will be like this. This is positive charge and this is also a positive charge, means force will be like in this direction. I am supposing this as charge 1. So due to charge 1, the force will be F1 is in this direction. And now due to this charge, if I want to calculate the force, this is positive charge and this is also a positive charge. So direction of means these both the charges will repel, means if you place a charge here, this charge will try to repel this with some force. I am supposing this as a charge 2. This is F2. Any problem till here?
No, sir.
Okay, that's fine now. Okay.
Yes.
This is purely the question of mechanics, not the electrostatics. Now we know the value of forces, how to calculate the force. We have the formula K Q1 Q2 by R square. Okay. Now if I want to calculate F1, F1 is a force in between this and this. So K Q and E divided by, we have to consider the distance also. Suppose I have kept this charge. I have kept this charge at a distance of, you can say, x from here. You can take the distance from here also, there is no problem. And this distance we have to find. So if this distance is x, the distance between this and this distance is x. So what will be this distance? Suppose this is a point O. Okay. So what will, and I am supposing this as A. Okay, no need to suppose. So please tell me what is the distance O between O and this charge E? This whole distance is A and this is x.
So A minus x.
Very good. So means this distance is a minus x. Okay. So now I can calculate the value of F1 K Q1, means I can take any of the charge E, and after that Q divided by the distance a minus x square. This is x. And for F2, these are two charges, 4E and Q. So K 4E and Q divided by, this is the distance between the two charges, x square. This is x now. Now this charge is in equilibrium, means these two forces should be equal. You can see here forces are equal now.
Yes.
Okay, so you can equate these two forces. Actually we are applying the vectors indirectly here. We are applying the vectors indirectly here. How? Let's see. I have told you that we will use vectors. This is F2. So this is a case of anti-parallel vectors. Anti-parallel vectors. And F1 and F2 are two vectors, but they are in equilibrium, means net force should be 0. F net at point at Q, you can say, equal to 0. So what will you do for equilibrium? Net force on here is a Q na? Net force is 0. Now you can subtract the two forces. If you find out the resultant, this is the resultant. Net force means resultant of two vectors, and force is a vector. So you can write F1 minus F2 equal to 0. So it means that F1 equal to F2. So that's why I am saying that here we have used the vector laws. And okay,
Yes,
so
sir.
it means these two forces will be equal. So I will equate the two forces. So what is the value of F1? K E Q divided by a minus x square. And what is the value of F2? K 4E into Q divided by x square. K gone, E and E gone, Q and Q gone. Means we have now 1 upon a minus x whole square and 4 by x. So if, can I take the under root on both the sides? In mathematics we do these things. If you will take the under root of this, so what I will get? 1 divided by a minus x, and here I will get 2 divided by x. This is x. So now we can solve this equation. We will cross multiply this. This will be x, and this will be 2 times of a minus x. So x equal to 2a minus 2x, and we have to calculate the value of x na. So I can write x plus, this will come here, this will become 3x. and this will become 2a. Okay, and we have got the value of x by 3. So this is our answer. And one thing more here is important. We have taken the x from this charge. Okay, so you can say x equal to 2 by 3 from plus 4a charge. And if I want to calculate the distance of this charge q from this charge, then what would I do? I will subtract a minus x. So you can say from charge plus e a minus x, that is a minus 2a by 3 will be a by 3 from charge plus e this distance. Okay, you have to put at a distance, you have to put the charge q at a distance a by 3. Okay, so that that charge will be equilibrium. This is the question, and I think this is a good question. Okay, so please note it down. This is very good question according to me, and please note it down. Have you understood this now? Last part, this part.
Yes, sir.
Actually, even I was confused when I was in 12th. So I was confused about the distances, from where the distances we have taken the distances, like from this charge or from this charge. But simply you should consider a distance from any charge. Like here we have considered the distance x from this plus 4e charge, and someone can take the distance x from here also. He or she will get the same answer. Okay, please note it down.
Yes, sir.
Completed whole
Yes, sir.
completed till here, na?
Yes, sir.
Okay, very good. So now you can ask me that here is a plus e charge and here is plus 4e charge. Why I have kept the charge q here? Why not here? Why not here? We can keep that charge here also, na? Here and here also. Why I have kept here? The reason is, if I am suppose if I am placing the charge q here. So now let's see. Due to this charge, what will happen? Suppose this charge is 1, this charge is 2. The force due to this charge will be in this direction, and due to this 4e, the force again in this direction. So can here the net force can be 0 here? Here the resultant means net force will be F1 plus F2, means always the force will be adding, means the resultant can never be 0. So that's why I have intentionally put that charge in the middle. And in the same way, if I am putting the charge here, what will happen? Due to this charge, the force will be in this direction. and again due to this charge the force will be in this direction, means they will never cancel each other. This is like, suppose charge as a body, this is a body, and suppose if someone is applying a 5 Newton force like this, and again someone is applying a 5 Newton force in this direction on this body, 5 Newton force. So can this body be in equilibrium? Malavika, can this body be in equilibrium?
No,
Never, no?
sorry. No,
Never.
sir.
It will never be in equilibrium. It will be only in equilibrium when the forces are like this. So same is the
Opposite.
same case is here. Okay. Same is the case here. So there is one more topic that I am going to discuss today is the types of equilibrium. Types of equilibrium. This is also the topic of 11th class from work, power and energy. So there are three types of equilibrium. There are three types of equilibrium. Stable, another is unstable, and number third is neutral. There are three types of equilibrium in this world. A body can be of in this three type of equilibrium. So for the equilibrium means net force on the body or a charge equal to zero for the stable equilibrium. And here is one thing, body will regain its position. So please wait for a minute or 2 minutes. Hello.
Yes, sir.
Okay. Uh, Body will regain its position by itself. And this and very beautiful example of this is, suppose here is a bowl or something, I don't know. Please consider this. Uh, this is not exactly the shape. Suppose if you have a cricket ball or something else here, you should imagine this. And suppose if you are displacing here net force is zero, na? Means ball is at the rest condition. And suppose if you are displacing this ball to this position. So Malavika, please tell me what would happen when the ball is at position 1 and now we move uh, this ball travel a displacement of this. We have put this ball here. So this can be seen as this ball will try to reach here, na? Try to regain its original position. Is it fine?
Yes, sir. Yes, sir.
Exactly, na? This is
Yes.
not the physics, this is the general question. This is not the physics. So this ball will try to move here like this. That's its original position. So this type of equilibrium is known as stable equilibrium. Stable equilibrium means the body will regain its position when we disturb the ball, when we disturb the body. And one thing more here is potential energy in this case is minimum. This is a minimum. Okay, this is the case. Actually, I think this lecture might be boring for you because we are dealing with the concepts of 11th class. But believe me, these are very important things. Okay. So here also, in case of unstable equilibrium, net force is zero, and again body will not regain its original position. And here, suppose here is, and suppose if I have placed a ball here and I have disturbed this ball, will this ball regain its position again or not? No. If I have displaced this ball, will this ball regain its position or not? Okay. Am I audible? Hello?
Yes, sir.
So please tell me, will this ball will regain its position when I disturb this ball from here?
No, sir. Cannot
No,
roll
na?
back up. No, sir.
Okay. Okay. So this is the condition of. So here you can write one point. Here the potential energy is maximum. And there is another case of neutral equilibrium. Here also the net force is zero. and body will be equilibrium at every point. At every point. And here potential energy is constant, and constant, you can take the example here, like suppose I am placing a ball here and I apply a force, this ball will come here. Again, I apply force, this ball will come here. So means here, when I am applying a force from here, this ball will move from here to here and this ball will stop here. Again, I am applying a force, this ball will stop here. Means at every point, the body is at equilibrium, and this is the case of neutral equilibrium. So please note it down.
Yes, sir.
Completed now?
Yes, sir.
Okay, good. Actually, we have 4 minutes more. Yesterday you have not got any assignment.
So in the portal, right?
Yeah,
I didn't see it there.
Okay, you did not see that. Okay.